Hi everyone, in this video we are going to see the implementation of our decentralized application. Here I have a folder and this is the same folder that we had in our class. So we have our contract here, it's the same contract. And we also have our decentralized application here called dApp. And here we have the source folder. So this is a React application, and this application we have our components here, and also we have our app.js. But first we are going to look at this file web3 client.javascript. In this file we have the implementation for our web3 functions. First we imported web3 from web3, and this web3 is the library that we are using to connect our backend, our solid code to our frontend. Next we have our ABI here, which is stored in this folder. Here we can see. Next, we have the selected account and the renter contract here. This will be the account that the user is using actively on MetaMask, and this will be the instance of our contract. Next, we have initialize variable here. And we are going to use this initialize variable to check if our contract is initialized or not, so we can run our functions. And this is our contract code here. And here we have our init function. This function is going to initialize our contract. We are having a provider here. This provider is what is going to connect our backend with our frontend. And we are going to say if the type of provider not equal to undefined, we are going to request connection. This means that if the user has Web3 enabled browser, then we are going to request to connect to MetaMask. And then we are going to say selected account equals account 0, which is the first account from the MetaMask. If there is an error, we are going to return. Then we are going to listen on address changes. So if the user changes his address, his active wallet address on the MetaMask, we can update our selected account here. Next, we created a Web3 instance using our provider. And then we got the network ID so that we can be sure that we are connected to the right network. After that, we created our contract instance here, and then we said is initialized true. So before this function, our is initialized was false. If this didn't happen, if this function didn't run, then we would know this from is initialized variable here. Next, we have a function here, get user address, and this returns the selected account so that we can use in other files in our frontend. And this is the section where we implement our functions from our Solidity code. First, we have the setOwner function. Let's see this part first. In this part, we are saying if not initialize, await init. So what we are doing here, we are saying if our is initialized is not true already, then first initialize the contract and then run this function. For that, we are saying await init because we want to wait until the initialization is finished. After that, we have a try catch block, and in this try block, we are saying await renter contract, which was our contract instance, and from this contract, we are tapping into methods of this contract, and then we are saying set owner. So basically, we are saying this is the contract that I want to have connection to, and from its methods, I'm requesting the set owner method. And for the parameter, we are going to pass our new owner parameter here, and we are going to convert it to the lowercase so that we would know for a fact that all addresses are lowercase, so there wouldn't be any compatibility issue. After that, we are saying send, and like our test here, we are saying from selected account. If this selected account is the owner, then we would know it's coming from the owner, and if not, it will be basically the user account. When we were saying message.sender in our Solidity code, it was basically this from here. And then we are returning this response, and if something's wrong with our process, then we are catching the error here, and with console.error, we are logging this error. So this is the ideology that we are going to use in our other function implementations too. First, we are going to check if our function is initialized or not, if our contract is initialized or not. Then we are going to create a try catch block. First, we are going to try to call the method that we want to call from the contract, and we are going to pass the parameters that we get from this function. Then we are going to say we will send this from this selected account, and finally we are going to catch an error if happens. So let's go with the register function here. This register function is going to add a user. We said register because it's more used in front end, so it will be easier. Here we made our check for initialization, and then we created our try catch block. In this block, with our try block, we tried to add a user using the renter contract.methods.addUser like we used here. And as the parameter, we passed our name and surname from our function parameters, and then we said we are going to send this from the selected account. We return the result, and if something is wrong, then we catch that error here. Next, we have the addCar function. Again, we have 3 steps. First, we are going to check for initialization. For the second, we are going to try to call the function, and for the third, if something is wrong, we are going to catch the error. And let's see which function we called here, which is addCar. And for this function, we basically pass the parameters from our function. Here we have the same ideology for the editCar metadata. We checked for initialization. Then in our try block, we called the editCar metadata from renter contract.methods, and then we passed our parameters. We said this is from the selected account. We return the result, and if something is wrong, we catch that error and we console logged it here. Next, we have the car status, which is the same ideology. As the parameters, we have ID and status here, and which we passed with the renter contract.methods.editCar status here, and we said it's from the selected account. We return the result, and if something is wrong, we catch the error. Next, we have the checkout with the same ideology. This time we are using ID as the parameter, and here we are saying renter contract.methods.checkout, and we are passing ID, and we are saying we are going to send this from selected account, and then we are going to return the result, and we are going to catch the error. So as you can see, we may have very complex and long functions in our Solidity code, or we may have some simple and non-complex functions in our Solidity code, but the way that we are calling them from our front end is pretty straightforward and same every time if there is nothing extra. And here we have our checking function. What's different here, we don't have any parameters here because we don't use any parameters in our checking function. What we did here, as the beginning, we check for the initialization, and if we are not initialized it, we are saying await init. Once we said await init, we are going to wait for this function. Then after this function run, then we will go to the try catch block. And this try catch block, we did what we always did so far. We said our result will be equal to renter contracts.methods.checkin, and we send it from the selected account. Here we said await because we don't want to move to the other line of code before finishing the execution of this function here. Then if something is wrong, we catched it with the console error here. Next, we have our deposit function. There is something different with deposit function. So in our front end, people are using 0.1 BNB or 0.05 BNB, 5 BNB. So users are using these tokens as they know. So they're not using them as the way or any that kind of style. So if we are going to give an example from this code, what we are doing here, we are actually converting from ether to way. So way is 10 to the power 18 ether. So since we don't have any decimals in the blockchain, we are working with way. Instead of saying 0.5 ether, we just say that 5 times 10 to the power 17 way. So with this ideology, since we have the same decibels with BNB as we have the same decibels with ether, we are saying we want to convert this value that we got as a parameter in that deposit function to way. And since we have the same decibels, this conversion will be alright, and then we are going to pass this as the value here. So let's look at this function with its entirety. First, we checked if we were able to initialize it or not. Then we converted our parameter to way. Then we said that we are going to call the deposit method here, and we said we are going to send this from the selected account, and also the value that is going to be passed with this function will be the send value that we created here from our BNB. And what's different here is we have this conversion and we also have this value, and this is the value that we were using in our Solidity code as the message.value, and that's where we were getting it. And then we are going to return the result, and if something's wrong, we are going to catch it here and console it here. Next, we have the make payment. In this method, we don't have any parameters, or we don't need to convert anything since we don't have any parameters. We are checking for the initialization. Then in the try catch block, we are calling make payment method, and we are sending this from our account, from our selected account. We are returning the result, and if something's wrong, we are catching it here. After that, we have the withdraw balance. We are doing the same process here as we did in our deposit function, the conversion, because our contract knows this big numbers, but users don't want to deal with these numbers. What they want to deal with is BNB. So that's why we convert it here. After that, in our try catch block, we are withdrawing balance. We are calling withdraw balance function with this converted value, which we call send value. And then we are saying we are sending this from the selected account. We are returning the result and catching the error. Next, we have withdraw owner balance, which is the same ideology. We are doing the same thing here. We are converting the value, and in this try block, we are calling withdraw owner balance, and we are saying we are going to send this from the selected account. Here, we had the only owner modifier in our withdraw owner balance function in our Solidity code. If this selected account is not the owner account, then we are going to have an error that we will catch here. Next, we have our query functions. These are also pretty forward. We also check for the initialization here, and if everything's fine, then we go to the try block, and inside this try block we are going to call the method. The way we call it a little bit different. We're still going to say await renter contract.methods.getOwner, and this is the method that we want to call. But instead of send, we are saying call, because this is a query function, not an execution function. This function doesn't change anything in our Solidity code, so we don't have to specify who is it from. For that reason, with these methods, we use call here. Then we are going to return this result by converting it to a string, and we are going to catch the error here. So it's the same ideology. The only difference is we are going to call it instead of sending the transaction. For the login function, we are going to say get user, and we don't have any parameter here because we are going to say this for the selected account so that the other users cannot log in for other people. And we are going to catch the error here. Next, we have the get car. We have the parameter here, and inside in our try catch block, we are going to pass that parameter to our get car function from the renter contract methods. Next, we have the get cars by status, which was returning us an array, and we are going to call it with the desired status here. It's important to remember with our status we had an enum, and in this enum we had three different fields: first, retired, then in use, and finally available. If the status is 0, that means retired. If the status is 1, that means in use, and if the status is 2, that means it's available. Next, we have our get current count function, which is the same ideology with every function that we taught. Next, we have two functions. These are a little bit different. So with these functions, we are saying result equals renter contract methods get contract balance dot call. So even though it looks like it's perfectly okay, the problem here is in our contract code, we said get contract balance can be only called by the owner. By looking at this function, there is no way that the code can know if it's from the owner or not, because we are not specifying who is this from in any place. So we need to specify who is calling this function for this specific case, not always. And here I'm also going to say this is from the selected account. And I'm going to do the same thing here. And this is our getTotalPayments function. This has the same ideology with the function here in our Solidity code. It was a view function, but we said only owner can call this function. And for that reason, we initialized the contract. We created the try catch block, and inside this, we are calling the methods from the renter contract, and specifically getTotalPayments method. And we are calling it by saying this is from the selected account, so that the Solidity part can know that this is from the selected account, so it can look if this is the owner or not. So this is how we can integrate our Web3 functions in our React code. And to give a quick overview, here we have our variables, we have our initialization function where we create our provider and also connect with the MetaMask. Then we were listening for account changes and updating our selected account accordingly. After that, we created our instance, we got the network ID, we created our renter contract instance, and we said that our initialize flag is true. After that, we created a getUserAddress function for further use in our front end. Next, we created our execute functions, and for that we had an ideology of 3 steps. First, we check for the initialization, then we created a try catch block. In that block, we sent the transaction to the contract through the methods from the selected account, and we returned the result. And if something was wrong for the last part, we catch that error here. And this was the same ideology here. What was different in our execute functions is that with this deposit and couple of other functions like withdraw balance, we were converting our decimals so that it would be easier to work with to the users. Next, we had our query functions. Here we were saying call instead of send because we didn't care who was sending this transaction in most cases. For that we had the call here, but on the last part we said call and it was from selected account. We specified this part because these 2 specific functions was looking for the only owner modifier in our Solidity code. To satisfy that condition, we added this from selected account part here. Next, let's see how we can integrate these functions to our React code. Here in our app.js file, we have our import. So we are importing the necessary functions from Web3 client here. The ideology is that we don't need to work with wallet creation or creating contract and everything in our React side. So we are putting the logic to this one file so that we can use these functions like an API. And here we have our states, and under the states we have our use effect. With this use effect, we are creating an asynchronous function here because we cannot say this is asynchronous directly. What we do instead is we create an asynchronous function, and after creating that function we call it here, and that way we can use effect asynchronously. Here we created handle init function and we set is a user equals await login. So login function, if you look at here, gets us the user. Here we are actually saying get user, and what we are going to get as a result from this function is the current user's information with the selected account here. Next, with this information, if we were able to get it, we are going to update our states. We are going to make this check here. We are going to check if the user's account is empty address or not. We defined the empty address on top. And if you remember, if we didn't have the user, what we were getting was the empty address. If we had the user, then we were going to get something other than the empty address, which is the user's address. Assuming that we passed here, we are going to say set logged in true so that our program can move forward. Next, we said set user credits. So this user credits is the user balance, and we are saying we are going to get the user balance, and then we are going to convert it from way to Ether, but we know that it's not Ether, it's BNB in our case. But since BNB and Ether has the same decimals, we are using Ether here as the coding language, but we are actually working with BNB. Next, we have the user due, which is basically the user depth, and we are getting this with the same ideology. Is a user.depth gives us the depth of the user, and this gives us the balance of the user, because with login we were actually saying get user and getting the user information. Next, we are setting our due here, then we are setting our username, and then we are getting the user address. If you remember, we created that user address part here, saying that we are going to need this later in our code. Here is our function. And after this, we set the owner to, so we can check if the admin has logged in or this is like a regular user, and we made the check here. After that, we created an empty array, and then we filled this array with the car status that are true. So meaning we filled this array with the available cars. After filling this array with the available cars, we also checked if the user's rented car ID is not equal to 0, this means that user has rented a car. And we also want to show this car in the UI so that user can check in the car they checked out earlier. After getting this car too, we are pushing this to our array and we are setting our cars array here. And this is the array where we saw our cars in the bottom of our web page. And then we have this section In this section, we are again checking the rented car ID of the user to see if user has rented a car or not. And based on this information, we are saying you can rent a car or you need to pay your due. The part that we do is here. Next, we have the right minutes section. So to calculate the right minutes, first we need to know if the user has rented a car or not. If they rented a car, then here we are getting the today's date, then we are dividing it with 1000 so that we can get it as seconds. Because if you remember, in our Solidity code, the start time in the user struct was seconds, so we are calculating the seconds here. Then by dividing it to 60, we are getting the minutes, and we are converting this to a string so that we can use it in our UI. And after our use effect, we have two functions. So if we are not logged in, if we did not register, then we are going to need to register to get the user name and last name and to pass it here as the parameters to our register function here, the name and the surname. We have these two functions so that we can get the input. And in this UI here, you can see how we integrate our Web3 part further. To give an example, here we have our div, and inside this div we have our cars array. If you remember, we were getting our cars array with the status of 2, which was available cars, and after that we were adding the car that user rented, if any. Here we are mapping this array, and then we are creating our car components and giving the fields of the car as the props here. In our car component, if you look at here, what we have is we have two functions, checkout car and check-in car. These functions are basically using our checkout and check-in functions from Web3, and they are just passing the parameters from the props. And here you can see we are saying we want to convert this from way, because what we were saying, we want to show this an easy to understand number to users. We don't want this 10 to the power 18 numbers. Instead, we want to show BNB. And for the BNB, we are converting our big number here. And with on click from these buttons, we are calling our functions here, which call our Web3 functions. So it's important to understand the ideology than understanding the UI exactly here, because what we are doing is we just have this file here where we create the connection with our Solidity code, with our contract, and we pass the parameters for that contract's functions. And as creating this file and separating this from the rest of the application, we have a section where we can use these functions as APIs. And after creating our normal UI, after creating our React app without any modification, then we can integrate these functions as they are normal functions, as they are any other functions. Instead, we are just going to get this from our Web3 client, and then we are going to call them. With this same ideology, we can create our decentralized applications. What we only need to do is, after we create our contract, compile it, and test it on Ganesh and testnet, we upload it for the front-end test on the testnet. After creating the front-end, we create our file here so that we can work with our Solidity code, and then we just use these functions as the APIs here. So this is the basic ideology of creating decentralized applications. I hope it wasn't too troubling. I know there are too many informations to grasp, but once we understand the ideology, how to do it, we can always check the code and our notes once we need help. But the important thing here is to understand the ideology behind all of this so we can work from there. Let's review what we did in this project. First, we created our MetaMask and we set our development environment. After that, we created our smart contract and test our contract using Truffle. After testing our contract, we deployed it and tested on the front end. Thank you very much.